So hello everyone, today we'll be learning about chapter 1, chemical reactions and equations of class 10th NCERT science. So here it's nothing but some daily life situations written here. But in all the above situations, one thing is common, that the nature and identity of the initial or original substance has somewhat changed. Now this is nothing important, so we will move directly towards the activity. What does this activity say? It says clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. Hold it using a pair of tongs, or hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash so formed in the watch glass as shown in figure 1.1. Burn the magnesium ribbon, keeping it as far as possible from your eye. What do you observe? So what they are saying is that we should take a magnesium ribbon just like it's here and rub it with sandpaper, clean it with sandpaper, and then using any kind of burner or any kind of flame we should burn it and collect the ash in a plate or anything you want. So we just need to collect this ash somewhere. Then they say, what do we observe? Now let us see what do we observe. You must have observed that magnesium ribbon burns with a dazzling white flame and changes into white powder. Obviously this was the expected result. This powder is magnesium oxide. Now this powder is magnesium oxide. So initially we had magnesium ribbon and now it has been converted into magnesium oxide. That means it has magnesium plus oxygen. It is formed due to the reaction between magnesium and oxygen present in air. So burning causes the reaction between magnesium and oxygen that is present in the air. Activity 1.2. Take a lead nitrate solution in the test tube. Add potassium iodide solution to this. What do you observe? Activity 1.3. So these are some activities. These are not very important. You can just read them if you want to, from the above three activities. But what is common in all the above three activities, or what we can determine from the above three activities, is that the helps us to determine whether a chemical reaction has taken place. So these are the things that can help us determine whether a chemical reaction has taken place or not, because these kind of things, as either one or all of them has happened in all of these previous activities. Either one of them has happened or all of them. So most probably all of them has happened. Help us determine whether a chemical reaction, here we can say that any of the following observations. So any out of it: a change in state, change in color, evolution of a gas, change in temperature. So either there should be a change in a state, that is from solid to liquid to gaseous state, there should be any change, or change in the color from red to blue to green to something like that. Evolution of a gas, it means there was something solid and then there was some and then the thing remained solid, but some kind of gas also evolved, some kind of gas was also released from its reaction. So suppose I burn this pen and this pen stays in the solid form, but some kind of gas is released which was not there previously. So still I would say that a chemical reaction has taken place by burning this pen. Now there should also be a change in temperature. Change in temperature also define whether reaction has taken place or not. Now if I start heating this metal tip of the pen and I touch here and suddenly my fingers feel hot, that means there has been a change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. So this is natural. Now that we have read the characteristics of a chemical reaction, we can easily determine that there are chemical reactions taking place all around us. Like for example, you can take some chemical reactions. The most basic and simplest chemical reaction is heating up of water. So whenever in our morning routine, when we drink hot water, or while taking medicines, or after eating something with ghee, we usually drink a little bit of hot water if we are thirsty. So what do? You pour some water into utensils and heat it up, and then the water becomes hot. Initially the water was cold, or it was in its natural state, but after you put it up on the flame, it heats up. So that is easily determined as a chemical reaction, because there is a change in temperature in the water. Okay, there is no change in state. It's liquid. It was liquid. It is still liquid. There is no change in color. Water doesn't have any color. But there is an evolution of a gas. A gas means, you cannot say it gas. It's just actually water vapor. So you cannot call it a gas. But there is a considerable change in temperature. There is a very considerably visible change in temperature, as we can easily feel it. Now, what are the chemical equations? What are chemical equations? When a magnesium ribbon, this description of a chemical, or you can say a description of a chemical reaction in a sentence form, is quite long. so it can be written in a shorter form. So a chemical equation is nothing but a chemical reaction written in a short form, written in a shorter and easier form. And the simplest way to do this is write it in the form of a word equation. The word equation for the above reaction would be, this is a word equation. Okay, this is the word equation for the burning of magnesium ribbon. So this magnesium ribbon, magnesium here represents the magnesium ribbon plus oxygen. Oxygen was formed due to the reaction. It means that magnesium reacted with oxygen. Why? Because it was burned. So burning or combustion of magnesium reacted to it resulted in its reaction with oxygen, which finally resulted in a product, and the product is what? Magnesium oxide. The product was magnesium oxide. So magnesium reacted with oxygen to form magnesium oxide. This is its simplest form. Magnesium reacted with oxygen, or magnesium was added to oxygen, oxygen was added to magnesium, which resulted in the formation of magnesium oxide. The substances that undergo chemical change in the reaction, magnesium and oxygen are the reactants. So substances that undergo changes or that show changes are called reactants, or the substances which react with each other are called reactants, and the final thing that emerges after the reaction is called the product. Okay, the new substance magnesium oxide formed during the reaction is the product. A word equation shows change of reactants to produce through an arrow placed between them. So or the right hand side of this arrow are written products, and the left hand side of this arrow are written the reactants. Okay, now moving on. Now we'll be writing, that was a word equation, and now we'll be moving on to chemical equation. Chemical equation is written by using the chemical formulas of different elements. So these are the chemical, this is the exact same equation that we just studied. That was written in word equation form, and this is written in chemical equation form. Now we are using the chemical formulas here. So the chemical formula of magnesium is Mg, the chemical formula of oxygen is O2, and the chemical formula of their product is MgO, that is magnesium oxide. Magnesium oxide is written as MgO. Is there some other shorter way of representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formula instead of words. Now we are using chemical formula instead of words. That's what I just said. A chemical equation represents a chemical reaction. A chemical equation also represents a chemical reaction, just like the previous one. So these are using the formulas of the elements. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. But what advantage does this give? Besides being concise and easier, it also tells us how many number of atoms are also used. So you can see this O2 here. The O2 here defines it. 2 atoms of oxygen are used. Since there is nothing with Mg, we will conclude it as 1. So there is 1 here with Mg. If there is nothing, we will just think of it as 1 here. So there is 1 atom of magnesium, that is Mg. Then there are 2 atoms of oxygen, and now these 2 atoms are already combined. These are still 2 atoms, but they are in a combined form. So the 2 atoms of oxygen, and what do they form? They form magnesium oxide. They form equal atoms of both of them, 1 atom of magnesium plus 1 atom of oxygen. Now you would say here they are actually a total of 3 atoms, but after the reaction there are total of 2 atoms. Here 1 atom is of Mg, 2 atom is of oxygen. Here 1 atom is of Mg and 1 atom is of his oxygen. Where did the other 1 atom go? So this equation is not balanced. This is not a balanced equation, right? There are different number of atoms at the left hand side of the arrow, and different number of from the number of atoms on the right hand side of the arrow, right? That's why this is called a skeletal chemical equation for this reaction. So equations which do not have the same number of atoms on left and right hand side are called skeletal chemical equation for that particular reaction, or you can simply say it as a skeletal chemical equation, right? You can simply call it skeletal chemical equation. So you can just read the definition here, or you can just go through the book text. Is the number of atoms of each element the same on both sides? If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation 1.2, this is equation 1.2, is a skeletal chemical equation for the burning of magnesium in air. Now we will study about balanced chemical equations. So what are balanced chemical equations? We have studied skeletal chemical equation. Now we should study balanced chemical equation. Recall the law of conservation of mass. Mass can neither be created nor destroyed in a chemical reaction. This is what the law of conservation of mass states, that during a reaction, mass is neither created during a chemical reaction, to be precise. Chemical reaction is nothing but a reaction between molecules of different chemicals or of same chemicals, and molecules are nothing but a bunched up group of atoms. So, the law of conservation of mass clearly states that mass can neither be created, it cannot be added, or it cannot be subtracted, that is destroyed, during a or in a chemical reaction. So the mass that is in the reactants should equal the mass that is in their products, right? That is the total mass of the elements present in the products of a chemical equation. In other words, the number of atoms of each element. And where is the mass? The mass is in the elements. So that means that the number of elements should be same. Sorry, the number of atoms. The number of atoms should be same on the right hand side and the left hand side of the arrow. So it means that the number of atoms that is in the reactant should equal the number of atoms that is in the product for the mass to be the same on both sides. Hence, we need to balance a skeletal chemical equation. Is the chemical equation but to balance? We have already said that it's a skeletal chemical equation, so definitely it's not balanced. Let us learn about balancing a chemical equation. Now we will learn how to balance a chemical equation if it is not already balanced. So this is the word equation, right? These are the examples. This one above one is a word equation. This is a chemical equation. Okay, both represent the same thing. However, zinc. This is zinc plus sulfuric acid. This is written in their formula. Zinc Zn plus H2SO4. That is nothing but sulfuric acid. Then it forms zinc sulfate. That is ZnSO4 plus hydrogen. That is H2. Right. So now let us count the number of atoms on both the sides. Zn has one atom. Okay, one atom on right side. On left hand side, then hydrogen has two atoms. On right hand side, hydrogen again has two atoms. Then on left hand side, sulfur has one atom. On right hand side, sulfur again has one atom. On left hand side, oxygen has four atoms. Right hand side, oxygen has four atoms. So this is a balanced chemical equation, because the number of atoms on left hand side equals the number of atoms on the right hand side. So this is a balanced chemical equation, okay, as is given in this table. Now let us consider another reaction. As the number of atoms of each element is the same on the both sides of the arrow, 1.3 is a balanced chemical equation. Let us try to balance the following chemical equation. So let us count the number of atoms here, just like we did previously. Fe1, here Fe has 3. So this is clear that it is not a balanced equation. Now we will learn how to balance a chemical equation. Okay, let us just go to our page in here and write our equation. It was Fe plus H2O, and what does it form? It forms Fe3O4. Fe3O4 is together, it's here, plus H2. So this is our equation. Now we will learn how to balance it. So we will move step by step to balance the chemical equation. First, draw boxes around each. This is just for our convenience. You do not actually need to draw boxes around it, but for convenience, while we're starting it, we should draw boxes. Do not change anything inside the boxes, however, while balancing this equation. So we will simply draw some boxes in around here. One box here, and then one box goes here, and one box goes here, and one box finally here. So these we have created boxes. Now moving on to the next step. List the number of atoms of different elements present in the unbalanced equation. So this is the number of elements on left hand side, and this is the number of elements on the right hand side, right? So step 2, it is often convenient to start balancing with the compound that contains the maximum number of atoms. So we should first start balancing the compound that contains the maximum number of atoms. It may be a reactant. It can either be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4. Since we can clearly see that the element that has the maximum number of atoms is the compound that has the maximum number of atoms is this. This has 4 plus 3, 7 atoms, whereas no one else has 7 atoms. So first we will try to balance this one. So how can we balance this? Fe here has 3 atoms, but Fe on the reaction side has only 1 atom. So we will need to balance both the atoms. So we will just write here 3. We will multiply. So what we are writing outside the box gets multiplied with the number of atoms inside the box. So here Fe has supposedly 1 atoms. Fe has here 1 atom, right? So if Fe has here 1 atom, then what does this mean? This means that Fe's 1 atom gets multiplied by this 3 here. So 3 ones are 3. So Fe also has now 3 atoms. And then O has here 4 atoms, but O here has only 1 atom, right? So we need to again write something like this. We write here 4. So 4 will also get multiplied with 2 also. See, it will get multiplied with both the elements atoms which are inside the box. So inside the box there is H also. 4 multiplies by 2, it becomes 8 atoms of hydrogen, and then 4 multiplies with O, then it becomes 4 atoms of oxygen. So we needed 4 atoms of oxygen to balance the equation. Then there are 4 atoms of oxygen, but we have extra atoms of hydrogen here. We have 8 atoms of hydrogen here, whereas there are only 2 atoms of hydrogen. So we need to put a 4 here. We put a 4 here on the right hand side. We can make changes on both sides of the arrow. Okay, consider this in mind while balancing the equation, that we can make changes to both sides of the arrows, not only on one side, not only on left side or right hand side. So now here 4 gets multiplied with 2, it becomes is equal to 8 atoms, right? It becomes here 8 atoms of hydrogen, and here are how many atoms of, here are also 8 atoms of hydrogen. So this equation has balanced now. This equation is now balanced. So the new equation that we would write would be like 3Fe plus 4 H2O, 4 H2O, 4 H2O, Fe3 O4 plus 4 H2. So this is our new balanced equation, right? We have changed it from a skeletal chemical equation to a balanced chemical equation. This was how to balance equations. Okay, so you can you know what, you can actually simply cross out these boxes. I just put these boxes to show you how to properly do it, so you don't forget how we did to make them balanced. You can just cancel out these boxes, no need to write these boxes, you can just directly write. So if you want to write, you can even write it like this: 3Fe plus 4H2O. This 4 here clearly will demonstrate that 4 is getting multiplied to both of them. This 4 is in kind of a constant, right? 4 is a kind of constant, so it will get multiplied with both of them. Then here we have our Fe3O4 plus 4H2, right? This is our final equation that comes out. Now let us match it. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the, yes, this is also how you can check your balanced equation yourself. You just need to match the number of atoms on both the sides. Is it same on the both sides of the arrow? Are the number of atoms same? If yes, then it is a balanced chemical equation now. So writing symbols of physical state, if you want to, you can also write the symbol of their physical states. In most of the chemical equations in your book, there would be written, these symbols would already be written there. So what does these symbols represent? Now we need to look at that. So these symbols represent nothing but their states, their states of matter. See, if you see something like this, you most probably see equations which are written like this, right? Equations are most probably written like this. It has 3Fe, then this small s, as you can see here, then 4H2 plus O, then small g here, then this small s, then small g. What do they represent here? See, they represent, S represents solid, they represent their states of matter. See, S represents solid, G represents gases, gaseous state, L represents liquid state, and AQ represents aqueous state, right? Aqueous state, it's not liquid, it's an aqueous state, more like a jelly kind of state. Okay, so we have balanced the chemical equation. Now let us move on. Now we will study about different types of chemical reactions.